Learning objective 6, equilibrium. So what we want to do now is take the knowledge we gained with the labor demand curve. That's determined by firms' decisions. Labor supply curve, determined by worker decisions. And we want to put these together into our typical equilibrium framework. So that's not too terribly complicated. So we're going to draw our labor market here. So we're going to have labor on the horizontal axis. We're going to have the wage rate on the vertical axis. And we determined labor demand was a downward sloping curve. Abbreviate that labor demand. Labor supply, the substitution effect dominates, is upward sloping with this vertical part representing a finite population, a finite size of potential workers that can work. And where these two meet is our equilibrium wage rate. We'll call that W star. And the equilibrium quantity of labor, I'm going to call that L star. So as simple as that. The equilibrium wage, W star, is such that the quantity of labor supplied equals the quantity of labor demanded. Equals the quantity of labor demanded. And that's equilibrium. Simple as that. Just as we did in chapter 4 with regular demand and supply curves. Now, what about unemployments? We talked about the three types of unemployment, frictional, structural, and cyclical. And in that equilibrium, if you noticed at L star, everyone who wants to work is working. Right? The quantity of labor supplied, the people who want to work at that wage, is equal to the quantity of labor demanded. So there's no voluntary unemployment. Is there any involuntary unemployment? And the answer in the typical model here is no. There is no unemployment. So who is unemployed? No one. You say, well, wait a minute, what about frictional unemployment? So this first model that we've drawn here is what we call a frictionless labor market. Meaning that I can basically instantly find a job. So I want a job, I can instantly find one at that wage. And we know that that doesn't really in particular make any sense. We're going to have to make some modifications and take a few leaps of faith here to make this model gel with reality. So what we're going to assume is that at L star, so just kind of remind you what our equilibrium looks like here. So we have labor and the wage, labor supply and labor demand. And the equilibrium clears that labor market at W star and L star. And what we're going to assume is that at that L star, we still have the frictional unemployment. So at L star, perhaps you can think of as implying the natural rate of unemployment, where we typically should be all else the same. Something close to that at least. Only frictional unemployment. And we're going to add in structural unemployment here in a second. So only frictional unemployment is occurring at L star. So even though there technically is an unemployment, we're going to assume that there is some unemployment, even at equilibrium in the labor market. So how are we going to get there? And how are we going to add some unemployment? How are we going to add this structural unemployment? Is what we call wage rigidity. And so what we mean by that is that the wage is fixed at some level. And we'll have some explanations in a second for why that might occur. But in the model, if I draw this out, so I have labor and the wage here, and I have labor supply and I have my labor demand curve, and here's the equilibrium wage, W star. So let's just say we'll make that a concrete number. That's $15 per hour. And we have some market clearing amount of labor L star. So wage rigidity is going to happen when the wage rate is fixed above the market level. So I'm going to call this WA for the actual wage right now. And notice what that implies is that the quantity of labor demanded, so I'll call that LD for labor demanded, exceeds the quantity of labor supplied, LS. And so that gap there are people that are unemployed structurally. So remember our definition of structural unemployment. It's unemployment that occurs when the quantity of labor supplied is persistently above the quantity of labor demanded, and that's exactly what we've created here. So the quantity of labor supplied, LS, is higher than the quantity of labor demanded. Why? Because the wage is stuck above the equilibrium wage, and the wage rigidity part here, we're going to assume that it can't go down. So why in the world would that happen? Right? So you might ask, well, if the wage wants to go down, why wouldn't it go down? Well, there's a number of reasons. One is wage contracts, and that can be of several forms. So, for example, you could have unions. And so what unions are very effective at, and why they exist, is they negotiate in a large group with the employer. So you get a whole bunch of people together, and they argue as one group that they should have a higher wage, and they're typically successful. And so that's going to cause the wage to tend to be higher than what would typically occur in equilibrium. So if you look at, look at the market for automobiles, and you look at automobile makers that are unionized, and their workers earn a higher wage than non-unionized workers. So the union was effective, and that causes the wage to be higher than the equilibrium wage. That's wage rigidity, creates structural unemployment. Another reason when I talk about wage contracts is typically you have a wage contract that's true for 12 months. So perhaps during the course of the year, my wage should decrease, but it doesn't, and that can also cause the wage to be higher than equilibrium. A second type of reason that wages can be higher than equilibrium is what we call efficiency wages. So what are efficiency wages? Efficiency wages occur as a result of employers willingly paying higher than the market wage. Right? Now, why in the world would an employer pay higher than the equilibrium wage? Well, there's lots of reasons. It can make workers more productive. Right? So if I feel I'm well paid, that makes me or gives me some positive feelings towards my employer, which may cause me to work harder. And it also decreases separations for the same reason. Right? So if I'm in an industry where turnover tends to be high, if I pay my workers a little bit more than the going rate, that makes them want to keep my job and not quit. And so there's lots of good reasons that employers would want to pay more than the going rate willingly, and we call those efficiency wages. And the last one, which we'll dive into more as we go through the course here, are minimum wages, which are wages above equilibrium by law. So the current federal minimum wage is $7.25 an hour. And when it's within a particular state, that could be higher than that federal minimum wage. And many states and cities, in fact, have wages that are higher than that. So these are the causes of wage rigidity. We've seen in the graph what happens. And so what I want you to do here is to go on Canvas, look at the question on Learning Objective 6, and see how you do on that. It'll help you understand these different types of wage rigidities and classifying them and how they might work in the model. And then we've got one last step here in this chapter, which is to understand how events are